Okay, welcome to the first webinar hosted by the First EduSpank Inc. My name is Vince and I will be your facilitator for this hour. So I've seen in the comment section there are people from San Beda College, Immaculate Conception, Green Hills. What else? What schools? GCF South Metro Christian School. We have from Malayan. We have from Corinthian School of Bocaue. Immaculate Conception Academy, St. Paul University, Manila. Okay, so again, my name is Vince, and I will be your facilitator for today. So currently, I am the program manager of First EduSpec Inc. I am also a CMA certified level 3 master trainer for VexIQ, and I also teach robotics and also special education. Okay, I am a special education teacher as well. Okay, so before I start my webinar, I want you to hit the subscribe button and ring the bell icon to give you updates on our future videos. Okay, so our agenda for today. So for our viewers, you're going to learn how to navigate the Vexcode VR, learn how to use the playground inside the Vexcode VR, learn where to get information about each block. For example, the help, we have the tutorials, so things like that. So an overview of the webinar. So this will run for 45 minutes. This is a 45-minute presentation, and we will be having a 15-minute Q&A session at the end of the stream. So questions will be or can be submitted via the comment section of this stream. So currently there are people who are raising encouraging, giving their backgrounds. Okay, that's good. Okay, so let's start. What is Vexcode VR? So Vexcode VR is a virtual platform which you can use to program your VexIQ robot. So it is a web-based, meaning you don't need to install anything. Okay, it is web-based. You just need to access the website for Vexcode VR. Since it is web-based, you can access it also through any device, okay, such as computers, laptops, tablets, and even your personal phones. However, when you're going to use your personal phone, be reminded that the space you have for programming may be limited. It is due to the screen size, so it is recommended to access it on a device with a much larger screen size, such as tablets. Okay. So why Vexcode VR? So developing coding solutions with a robot provides irrelevant context for engaging students in computer science. Robots with sensors and physics integrate computer science into STEM, or now what we call STEAM. We have added the arts. Virtual playgrounds help to contextualize STEM learning and authentic student inquiry. So later you'll know what is a virtual playground. Okay. Next, activities provided have a structured and approachable STEM learning experience. So Vexcode VR knowledge and principles translate directly to VexIQ and other VexIQ or Vex platforms. So it is very easy for the students to learn Vexcode VR because the programming quirks and features are just similar with VexIQ Robot C. It's just that there are added features. Vexcode VR is just a supplement. Again, Vexcode VR is just a supplement and not a replacement with your physical robots. The Vexcode VR team tried to make this for students of at least 1.5 billion that are only at home, and millions of teachers that at home at their living rooms and trying to find out what's the best approach for their students to learn while at home. So here are some of the Vexcode VR features. So it is web-based. So again, you don't need to install anything. You just need an internet connection and a device. Virtual robots. So there is a virtual robot. It is already pre-built. It uses drivetrains and sensors. And it also has an added feature, which is the pen. So later you'll know what is the pen. Virtual playgrounds. So just like what I said, I'm going to discuss this one later once we are already in the interface of the Vexcode VR. Programming language. So it is similar to VexIQ Robot C with just an added feature. So challenges and activities. So there are challenges and activities that are already preloaded in the Vexcode VR, but I would like to take this opportunity to invite you all to our virtual camp. Okay, so our team will give you interesting activities to the students who are able to enroll. This virtual camp that we're hosting is 100% free. Again, it is 100% free and open to all students of our partner schools who want to explore robotics while at home. This virtual camp is also open to our non-partner schools. Again, this is also open to our non-partner schools, but has a limited slots. So I suggest you enroll now. Next, we have the live dashboard. So it lets you visualize data on the playground's dashboard. So later, we'll get into that. Supported browsers. So for this one, if you're going to use Windows or any Windows device, you can use Microsoft Edge or the Chromium. We have also the Google Chrome and the Mozilla Firefox. Sadly, I wasn't able to try it on Safari, but I suggest and I also recommend to use the Vexcode VR on this browsers. So if you're using the Mac OS, Apple Safari is also supported, Google Chrome, and also Mozilla Firefox. If you're having your iPad, I suggest you use your Apple Safari. For the Android devices, Google Chrome, and also to our Chrome OS. So now, what are the parts of the robot? So this robot is specifically designed for the Vexcode VR or the virtual reality. So here we have on the left side here, we have a pen. Again, what I said a while ago, it is an added feature. We have a pen here. We have an electromagnet down there, so it's facing down. We also have a down eye, so later you'll know what is that. We have a 50mm diameter wheels there. And on the right side here, as you can see my mouse, here we have the built-in gyro plus location sensing. Okay, so location sensing or sensor. So later you'll know what is that kind of sensor. So in front, we also have a front eye plus distance sensor here. And on the left and right side of the robot, we have the bumper sensor, the bumper switch sensors. So getting started. So I'm going to close for a while this one while I switch to my browser. Okay, so here I have the Vexcode VR. So sir, how can we go to the Vexcode VR website? So here, as you can see, we have the vr.vex.com. So you can manually search it as well, or you can just type it in the address bar. It's just vr.vex.com. So that is vr.vex.com. Or if you try to manually search it, just type. So I'm going to open a new tab. Just type Vexcode VR. And then the first link that will show up, just click it. And then here at the middle, you will see go to vr.vex.com here. Okay, so you can click that one, or you can just type vr.vex.com. So I'm going to close the other tab. So I'm just having this one. So just a quick review. Since Vexcode VR is web-based, you can access it to any device. However, again, it is not recommended to use in any smaller device than a tablet. So any device with a large screen will do. Okay. So now for the navigation. Okay. For the navigation, so let's start at the upper part of the interface, starting at the left. So I'm going to open up my magnifier. So there we have the VR logo. Next is the globe icon. So if you click this one, you're just going to change your language. So let's just select English. Next, we have the file. So if you click file, under the file menu, you will see the new blocks project, load from your device, open examples, save to your device, and about. So for the new blocks project, so whenever you want to create a new file, this is where you need to be. So just a reminder, whenever you create a new file, please make sure that you have already saved your current file, because your current file will be discarded. So for example, I have here, for example, this is my my file. So as you can see, I wasn't able to save it. If I click file and new blocks project, it will prompt me, your project was never saved. Save now. So you can just click save or discard. So I'm going to discard it. There. Next, we have load from your device. So basically, it will just give you an option to load a previously saved file. Next, we have open examples. So when you click open examples, a list of examples will be shown to get you started. So for example, this one, I'm going to click it. There. So this is the examples. So it has a filter system that sorts the 40 plus examples. Again, we have 40 plus examples based on the contents of the program. So you can see all. We have the drivetrain, looks, control, sensing, operators, and variables. Okay, now, so since you already have a glimpse, or you already know what is the URL, I'm going to have it full screen. There. Next, let's have the save to your device. So whenever you click save to your device, it will automatically download and save your file in your downloads folder. Again, it will automatically download and save your file in your downloads folder. Notice I did not log in or even create an account just to save my program. The reason is that Vexcode or the Vexcode VR wants to emphasize access or the easy access to students that are using tablets, laptops, computers. But whenever you change something in your program, you need to save your program again. Again, you don't need to create any account just to save your program. So when you want to open your file, just click load from your device, from this one. So if you're a teacher and you're going to use Vexcode VR, all your students have to do is to email their programs to you. Just go ahead and open it and see if their programs are correct. So for example, here I have my current project. So I'm going to click save to device. When I click save to device, as you can see down there on the lower left, it says that my program is already downloaded. Okay, so I'm going to switch my screen just to have a bigger view. There. So as you can see now, we have the file there down, okay, on the lower left part of your screen. So I'm currently using the Google Chrome. So if you're also using Google Chrome, this is what we're going to do. Just click download and automatically it will save your file. And lastly, we have the about. Okay, so everything is in there: copyright, privacy policy, and acknowledgements. Okay, next we have the tutorials. So here, tutorials. So here, currently we have 3 tutorials to get you started. We have the getting started, naming and saving your project, and also using the playground window. So a very cool feature to work with the Vexcode VR is that whenever you try to watch a tutorial, for example, here I'm going to click getting started. So whenever you try to watch a tutorial, you can still continue to work with your program. So it will open up a new window that will overlay to your workspace. So there. This is my workspace and this is the tutorial. So we can play this one.
With Vexcode VR, you can program a VR robot to do many things.
Okay, and then if you want to edit your program, you may do so and the tutorial will not disappear. Okay, so that's it for the tutorials. Again, we have 3 tutorials that you can watch: getting started, naming and saving your project, and using the playground window. So I'm going to click back. Next, we have the activities. Still on the upper part, we have activities beside tutorials. Here, activities. So if you click activities, it will direct you to a different tab that contains free activities for the Vexcode VR. So I'm going to zoom out a bit. And then I'm going to click the activities. So when you click that one, a new window will appear for this one. Okay. So these are the free activities that Vexcode VR has provided us. So I would also like again to take this opportunity to invite you to our virtual camp. Again, our virtual camp. Our team will give you new interesting activities to the students who are able to enroll. This virtual camp that we're hosting is 100% free and open to all students of our partner schools who want to explore robotics while at home. This virtual camp is also open to our non-partner schools but has limited slots only. So I suggest you enroll now. Okay, so going back to my screen, I'm going to close the Vexcode VR Activities tab. So we're here back to our interface. Next, we have the Vexcode project. At the middle, we have the Vexcode project stated there. So in Vexcode VR, all projects begin with a default name of Vexcode project, as you can see here. That is the default name. So if you want to give a different name to your project, just select the project name and name it from your toolbar. So here, I'm going to click Vexcode project, and then it will prompt you to change your file name. So here I'm going to type getting started. So this is our first time in creating our file. Click rename, and then there, getting started. So whenever you try to save your program, instead of having the Vexcode project as your file name, this will be your file name. Okay, so let's try. So I'm going to file and then save to device. So as you can see here at the bottom, I'm going to change my window. There. So as you can see, getting started that VR blocks, and we have here our previously saved file, the Vexcode project. Okay. So we're done with the Vexcode project here. Next, let's have the playground. This is our playground on the upper right corner. So here in our playground in Vexcode VR, you can program a VR robot to complete your activities in different environments called playground. So in Robot C, we have the virtual world. Here in Vexcode VR, we call it the playground. So by default, playground will load a grid map for this one. So I'm going to zoom it. So this is our playground. We have here the grid map. So when you click the grid map, a drop-down menu will show up listing all the available playgrounds. So we have the grid map, art canvas, disc maze, wall maze, number grid map, disc transport, and the castle crasher. So each playground ranges from negative 1000 millimeters to positive 1000 millimeters for the X and Y axis. So the starting position of the VR robot depends on the playground selected. So here we have the grid map. I started at the lower bottom. So but when I try to change this one, there. So it changes the default location of your robot. So I'm going to go back to the grid map. Next, we have the expand. Expand, which lets you have a bigger view of the playground. If the playground is expanded, there, you will see a bigger screen. Next, if you click shrink, it will give you a smaller view. Next, we have the hide, which basically hides the playground, but the toolbar is still there and it is movable. So for example, I click this one, hide. So there we have here still the toolbar, and I can still able to, you know, program this one. Next, we have the activities. So activities will just like what we did a while ago, it will just direct you to our Vexcode Vr activities on a new tab window, just like the activities on our blue toolbar for this one. So it is the same. And then we have this one, the close. Okay, so if you close this one, it will close. So this is different from the hide. If you click hide, the toolbar is still there and you can move it around your interface or workspace. But if you close it, the whole playground will close. Okay. So under the brown toolbar, this one, we will see the live dashboard. So this is what I'm talking about a while ago. This basically gives you a live update of the heading, rotation, front eye, down eye, location, location angle, bumper. So again, we have two bumper switches, the left and the right, and the distance it detects. Okay, so on the lower right side of the playground, we have the camera views and a button to hide the live dashboard. It's this one. So here, if you click this one, it will hide your live dashboard. I'm going to click it again to show it up. And we have here the two camera views. So for the camera views, we have two. One is the top down here. This one, top down view. You will have a top view of the robot and the playground. And this one, on the second one, we have the chase view. If you click chase view, it basically follows your robot wherever it goes on the playground. If you click on the playground here and move your mouse, I'm going to click and move. The view changes, but it's still locked into the robot. Okay, the robot is still at the center. So you can also zoom in and out by using the scroll wheel of your mouse. I'm going to zoom out and zoom in. Okay. Next, we have the start, step, and stop, which helps you control your robot. This is beside the playground. And next, we have the share. This one, the share. This is a very cool feature of Vexcode Vr, as it lets you have an image of your program saved as PDF when you click it. So we will try this one later once we get into the programming part. And lastly, on the upper right, we have the feedback. Okay. At the bottom of the share and feedback button, we have the help. So when we click help, this one, I'm going to click it again. This is our help. As you can see my mouse, when I click it, it will have an overlay of help. So for this one, in order to use it, you need to select a command block. For example, I'm going to select the drive forward here on the left. Select this one. And then here on the help, it will give you all the information you need. So whichever block that you want to learn more, you can just select another screen. So here, for example, I'm going to select turn, and then the information for the turn will be there. So this is very helpful, especially if you're a beginner. Okay, here at the middle, you will see when started. This one. So basically, it is just where you will branch your command blocks in order for it to run. Okay, so everything here on the left side will be branched out here. And then when you run your program, everything that is connected to when started will run. Okay, next. So I'm going to try to drag one command block. So here we have the we have the drive forward. So when you right click this one, So one of the features of Vexcode VR is to disable a command block without removing it. So just right click the command block. Here we have the drive forward, right click, and you will see there duplicate, disable block, and delete block. So you can select disable block. Okay, so you're not going to remove it, but basically it will just disable that command block. And then we have the deleting command blocks. So there are 2 to 3 ways to delete a command block. You can right click the command block. So we have here the drive, right click, and then select delete. So it will automatically delete your command block. So I'm going to drag another one again. Another way of deleting a command block is by selecting it, hold it, and then drag it back to the left side. So it will delete your command block. Third one is select your command block and press delete on your keyboard. Again, select your command block and then press delete. So that's basically it. Let's move on now to our left side, the left side part of the interface. So on the left side of the interface, we have the command blocks. So it is in a filter system again that sorts every command block based on its use. So everything is drag and drop here again. Everything is drag and drop, just like in Robot C. You just need to connect it on. You just need to connect it to the branch of when started in order for the block to work. So for the different filters or categories, we have here on the left side, I'm going to zoom it. We have here the drivetrain, magnet, looks, control, sensing, operators, variables, my blocks, and comments. So basically here, let's start with the drivetrain. It contains the basic commands of the VR robot, like the drive. For example, here when I click it, when I drag it there, drive forward or reverse. Okay, so the drive block, this one, turns on the drivetrain continuously. So you need a condition for the VR robot to stop it. You can go forward or reverse. Here, forward or reverse. Next, we have the drive for block. Here, drive for block is somewhat similar to the forward command of Robot C. It lets the robot drive forward or backward for a specific distance. You can select millimeters or inches. So where? Here, if I'm going to select mm or millimeters, we have here the option to select millimeters or inches. Then here, drive forward or backward. So let's go ahead and try this one. So I'm going to open Playground. There. So this is our playground. If we click play, there. So basically the robot drives forward for 200 millimeters. Next, so I'm going to delete this one. We have the turn right and turn for blocks. So basically, this lets you turn your VR robot to the left and right. So turn right, just like the drive forward. Here, the turn right is just it's just like the drive forward. It will continuously run. But here we have the turn right for 90 degrees. If you select this one, it has already a condition that it will turn right only for 90 degrees. Next, we have the turn to heading. This one. Still, we are under the drivetrain. It is color coded with blue. Turn to heading can be used to turn the drivetrain to any given clockwise heading. So it accepts a range from 0.0 to 359.99 degrees. It accepts decimals, integers, or numeric blocks. There. So if you want to learn more on that block, you can just click help. Again, it's on the upper right of the interface. Just click help and then click turn to heading. So everything or all the information about that command block is there. Next, we have the stop driving. Stop driving is like the stop all motors of the Vex IQ Robot C. So it is used together with the drive forward block. So here, I'm going to give you an example. So drive forward, and then I'm going to use a wait command and drag the stop driving. So here I'm going to select 5 seconds. So I'm going to hit playground. So whenever you try to run your program, you just need to hit the playground or click the playground and then press play button on the left side. So play button. There. So basically the robot will run or drive forward for 5 seconds. Then it will come to a complete stop. So if I want to reset, there, just click this one, then play. Okay, so I'm going to close the playground. Next, we have the set drive velocity 2. This one. So we have there set drive velocity to 50% and set turn velocity to 50%. So basically for this one, it lets you change the speed of your drivetrain. So it accepts 0 to 100%. Just like in Robot C, the default velocity of the robot is 50%. You can change your robot speed with this one. So here, when started, I'm going to delete my previous programs or commands, and then I'm going to create a new code. So here I'm going to drag set drive velocity to. Here I'm going to put 75, and then I'm going to drag drive forward for 200 millimeters. I'm going to change this one to 500. Click the playground, and then just click play. Okay, so there you can explore more of this one. So here, let's try setting up a drive velocity of 10. And then we're going to have a drive. So I'm going to hide this one. Drive in reverse for 500 millimeters. So we're going to click stop and then show the playground. Then click play. Okay. So if you want to learn more of these command blocks, you can always go to help, or you can just enroll to our virtual camp. So I would like again to encourage or take this opportunity to invite you to all to our virtual camp. So our team will give new interesting activities to the students who are able to enroll. This virtual camp that we're hosting is 100% free. Again, this is 100% free, so enroll now. Okay, next we have the magnet. Magnet is basically sets the VR robot magnet to do two different modes. We have here energize magnet, then boost here, boost or drop. Boost basically attracts an object to the magnet, or drop releases any object the magnet is holding. So the VR robot has an electromagnet to pick up and put down discs that contain metal cores. The electromagnet is located at the front of the robot, so pointing down towards the playground currently in use. So if I want to use this one or utilize this one, I would suggest you try to use the disk transport challenge. There. So this is the disk transport challenge. We have here, as you can see, I'm going to zoom it. This is our robot. And then there are those disks that are magnetic. Okay. So I'm going to try to program this one. Okay, so I'm going to drive forward. I'm going to hide this one. Drive forward, let's say 700 millimeters. Turn left. So I'm going to drag turn left. Click right to left for 90 degrees. Then I'm going to select the energize. Energize to boost. And then wait. So under control, wait for 2 seconds. And then energize again. Then set it to drop. So basically what this program does is that the robot will drive forward for 700 millimeters, turn left for 90 degrees, activate the magnet or the electromagnet. So we have the boost, and then wait for 2 seconds, and then the magnet will drop the item. So I'm going to run this one. Oh, so we have forgotten to put this one. So let's set it to 300. Going to stop the program, show it again, reset, then play. There. Okay, so that's how the electromagnet works. Next, let's have the looks. So I'm going to close this one. The looks, we have here the pen. So this is for the pen. We have two command blocks. We have move robot pen, up and down. So basically it will just let you to put up or put down the pen. And then set robot pen to color. So you can select black, red, green, and blue. So once again, very simple edit here. You can just quickly launch the playground. Very easy, very fast, good learning. And this is also good for teaching. Next, let's have the controls. So this section lets the programmer make conditions for the robot. The VR robot then uses its sensors to detect if a condition is true or false, or just loops the command blocks. So control blocks or conditional blocks utilizes circular and hexagonal spaces, as you can see here on the left. So we have there the circular spaces, this one, and we have the hexagonal spaces for the if and then the if else. So these blocks are very flexible. You can use it with other circular and hexagonal spaces, but make sure that your code contains a valid argument. Next, we have the sensing. So here for the sensing, we have different categories or sections. We have the brain sensing, drivetrain sensing, we have the bumper sensing, distance sensing, eye sensing, and this one is the location sensing. So basically, for the brain sensing, it uses the timer of the brain. The drivetrain sensing can be used with controls that utilizes hexagonal spaces and circular spaces. For this one, driver is done, drive is moving, drive heading in degrees, drive rotation in degrees. And then we have also on the left side the bumper sensing. So here it's a hexagonal space. So the robot has again two bumper switches on both sides. So you can use the block to detect walls, just like our bumper switch in our robot C. Next is the distance sensing. It utilizes the distance sensor in front of the VR robot. So just like what I have showed you a while ago, we have distance sensors in front and at the bottom. So as you can see here, as the teacher progresses discussion, topics could get a little harder as you see. So teachers, you guide, okay? Sensing, under sensing, and then click distance. So it will prompt me. So it just discard it. So here we have a simple program for the distance sensing. So I'm going to start this one. Okay, so let's go back to the grid map. Then I'm going to play it. So again, giving your students the solution to the hurdles they face may make the project move along. The answers may seem easier in the short term. It doesn't help students develop the computational thinking, okay, which are critical to succeeding in educational robotics. So when you notice a student is struggling, help them, encourage them, but then let the student know that troubleshooting is a part of the process. Guiding students to reflect on the project's design, planning, and develop processes which help to advance their metacognitive abilities. Ideally, students will be able to recognize how a subsequent project can be better developed. So after gaining valuable hands-on insight. Next, we have the eye sensing here. So we have the front-facing eye sensor also acts like a distance sensor and returns the distance of a detected object in millimeters and inches. So if you want to learn more on that, you can click help again, and then all the information will be there. So here we have the location sensing. For the location sensing, it basically reports the X or Y coordinate position of the robot. So if I go to playground, as you can see in our live dashboard, there is the location. So currently the robot is placed in -900 millimeters for the X and -900 millimeters for the Y axis. So we have the X axis and the negative axis, or we have the Y axis. So we have both in the negative side. Next, so I'm going to close this one. Next, we'll be having the operators. So for the operators, this section gives the programmer the flexibility to program the robot. So for example, here, a circular space added to a circular space, subtract, multiply, and divide. You can also pick random numbers from 1 to 10. And then we also have the end. We also have here the greater than and less than or equal for the checking of inequalities. We also have here the and or not. That's the logical operators. And here, lastly, we have the functions that lets you round off values and perform math functions and get remainder. So for example, I click the help here. If I click this one, there, so the ABS stands for the absolute value, floor, ceiling, square root, sine, cosine, and many more. Okay. Next, we have the variables. Still on the left side, we have the variables. So for the variables, just like in Robot C, variables are places to store values such as sensor readings for later use or for use in calculations. So there are 3 steps involved in using variables. So if you want to learn more on that, again, I'm going to take this opportunity to invite you all to our virtual camp. Our team will give new interesting activities to the students who are able to enroll. So this virtual camp is that we are hosting is 100% free. And also don't forget to hit the subscribe button and ring the bell icon to give you updates on our future videos. Next, we have here the My Blocks. For the My Blocks are used to create a sequence of blocks that can be used multiple times throughout the project. So here, I'm going to zoom out. So this is like a function in Robot C. If you want to learn more on this, you just click help. So here, if I click make block, click OK. So a new defined block will open up. Then click block name on the left side. Then all the information will be there. Okay. Next and lastly, we have the comments. So for the comments are used to describe your code to help you and your teammates understand the program better, right? So these are texts that are part of your program that will not be sent to the robot when you download this one. Okay, so when I click comment, this block will not be sent to the robot. It is just for you to have additional texts which you can use to understand your program better. Okay, so that's it actually for the interface of the Vexcode VR. You can, I think this stream will be recorded automatically by YouTube. So you can go back here if you want to double check something, or you can enroll to our virtual camp, which gives you more activities, guides for the teachers, and many more. So that's it for our navigation of Vexcode VR. So I'm going to go back to my PowerPoint. Let's have the Q&A session. So there will be facilitators in the comment section to answer your questions. Okay, for the Q&A. Okay, so when you create a file and you try to save this one, for example, here the Vexcode project, here, so I'm going to click the Vexcode project, name it Getting Started, Click rename. And then when I try to save this one, save to your device, all the files that you save will have an extension file of VR blocks. So you're only able to open this one through the Vexcode VR interface. So if you're a teacher and you're just having your mobile phone with you without a tablet or computer or laptop with you. So for example, a student of yours have created a file and you won't be able to open it. For example, so if, for example, I have here the drive forward. Again, this is just an example. And then set drive velocity. If we have, for example, the students have this kind of code, we have here the share button. Again, the share button on the upper right corner. If you click share button, the file will be downloaded as PDF. Okay, we have here the getting started .pdf. So that's the one that you clicked for the share button. So if I click this one, you'll have this one. This is the code of your student. Okay, so that's a new cool feature of the Vexcode VR. So just a quick review. This Vexcode VR is web-based, so you just need to access Vexcode VR through the URL vr.vex.com. So that is vr.vex.com. So this can be opened with your iPads, tablets, laptops, or personal computers, and it will save with an extension file of VR blocks. So this can be opened again through this one, the Vexcode VR interface. Just click open and load from your device. You just need to locate it. So while my facilitators are in the comment section, so I think I can show you an example of a program. I'm going to close this one. I'm going to file, open examples, going to looks. Then here, I'm going to click draw a line. So this is an example file. So again, it will prompt me that I have saved yet. Discard, and this is the example file. So when I click playground, and let's have the chase view for this one. Click play, there. So the robot is using the pen. So let's break down the code. As you can see here, it is entirely inside the repeat command or repeat C block. And then we have move robot pen down. Why down? Because the default location of the pen is facing up. So you need to select move robot pen down. Drive forward for 200 millimeters. So that's your condition. And then move robot pen up. Okay, so it will automatically move up. Here you can also modify this one. Let's have the looks. Set robot pen color. Let's change it to red. Going to stop the program. So here in our grid map, in our playground, click reset and then play. As you can see, there is the red line that is drawn by the pen. So for the submission of your output, again, you can save your file. As you can see here, just click File, Save to Device. If you're going to save to your device, it will move to your Downloads folder. So for this one, I have here the saved files at the bottom. So there. So these are the files. You just need to open it and save it. You just need to open it and then send it to your teacher or to your classmate. So for our virtual camp, there will be different outputs of the students. Okay, so no more questions. Okay, so that's it. Thank you all for joining all the way from School of Ika, Immaculate Conception Academy, San Beda, Alabang. Thank you all for attending and join and ring the bell icon to give you updates on our future videos. Thank you.